Welcome to Cisco Networking 1 modular class. So let me introduce to you our MCC Cisco team. So we have Engineer Ernie Pineda, our Cisco lead main contact, and yours truly, Engineer Dennis Takadena, Cisco lead or the MCC Cisco lead. We also have other instructors. We have Dr. Jocelyn Sanguyo and Engineer Darwin Pineda. So to start our discussion under Introduction to Network, let me start of the composition of the grading system for this modular class. So we have 20% online modular quiz that will be done using your Edmodo account. Another is 20% online modular exam using the official website of netacad.com. Another is the 20% take-home packet tracer activity. So that will be the submission using your Cisco NetAcad account. And lastly, the 40% final online exam using your Cisco NetAcad account. So overall, your semester grades, that will be the computations. So let's start the chapter 1 discussion. So networking today. So our module objectives is to explain how networks affects our daily lives. Another is explain how host and network device are used. Explain network representation and how they are used in network topologies. Compare the characteristics of common types of networks. Explain how LAN and WANs interconnect to the internet. Describe the 4 basic requirements of a reliable network. Explain how trends such as bring your own device, online collaboration, video, and cloud computing are changing the way we interact. Identify some basic security threats and solutions for all networks. And lastly, explain employment opportunities in the networking field. So to start, so how networks affect our lives. So nowadays, communication is almost important to us. So you can communicate with your parents, loved ones, and friends using your mobile phone or laptop, desktop, for as long as we are interconnected with the ISP or internet service provider, we can exchange informations and thoughts to our loved ones. Using your Cisco NetAcad official sites, check it out, log on. There's a lot of resources there. You can download the packet tracer. You can browse all the activities as well as the readings and videos that is already equipped on that sites. So networking today, no boundaries. Why? Even though we are separated with large geographic areas, even though we are on the mountain, for as long as there is a cellular sites coverage or satellite transmission, we can communicate to our loved ones and friends. Network components. What are the network components? So we have here a host role. So every computer on a network is called host or end devices. So we have example here are the clients and server. So servers commonly, we have a common server like email, web server, and file server. Or if you have a Gmail account or Google Mail and Yahoo Mail or Rocket Mail account, that is an example of email server. Web server, if you are browsing through internet for us using search engine, so you will be forwarding to, or you're browsing to different web servers around the world. File server, example of these are the repository for your files. Example of these are your Google Drive, your Dropbox, Mega Upload, or even the streaming sites like YouTube. So you can upload your video, and about Facebook, you can attach files using your Messenger. You can create a groups on a Facebook where you can share your resources. So clients are the computer that send requests with servers to retrieve information. So your computer, laptop, handheld portable device, smartphone, once you are using it for browsing or surfing through internet, those are client's computer. So peer-to-peer connection. So as you can see, we have two computers interconnect to each other using a cable. Probably this is a crossover cable. And the other one attached here is not a crossover. Probably this is a USB cable attached to a computer. This is a peripheral. If this is a network printer, that this will be considered with two network interface card. So once we are using peer-to-peer, crossover cable is used in this. What are the advantages? Easy to set up, less complex, lower cost, and used to simple tasks by transferring files and sharing files. You already done this using your previous course, the IT Essential. End devices. So what are the end devices? An end device is where a message originates from or where it receives. So this is the source of the data transmission or the destination that will be the recipient of the receiving data. So those are end devices. How about intermediary devices? Example of these are the switches, router, access points, and firewall. So their main purpose is maintain information about the pathway exists to network, generate and retransmit data signals, notify other device of error and communication failure. So they are responsible for path transferring of data from the clients and forward that data or packet to the end device. Network media. So you already learned this on your IT Essential course. So we have a cable, wire, and wireless, and the fiber optics using light transmission. So metal wires with cables, those are examples of UTP and STP, or the unshielded twisted pair, the shielded twisted pair, coaxial cable. Another is the fiberglass or fiber optic using the light transmission. And lastly, wireless transmission using your wireless fidelity or Wi-Fi using the radio frequency for the transmission. So network representations and topologies. So what are these? So the network diagrams, or called topology diagrams, used to symbol to represent this device within the network. So if you look at the right side, so those symbols are used using your packet tracer software. You will, I already discussed how to use the packet tracer. Those symbols you will be seeing on the software. So important term, the network interface card, or simply the LAN card, Ethernet card, are a card that been put on the desktop computer or devices for as long as it can be given an IP address with MAC address. So those are the network interface card. Another topology diagram. So we have physical topology and logical topology. So we have here the illustration of physical location of intermediary devices and cable. So we are talking about the equipments and end devices. So those are physical topology. How about the logical? So we are concerned with the addressing. Example of these are IP address, IPv6 address, and your MAC address or the physical address of your computer. Common types of network. So networks of many size. We have a small home, the SOHO, medium large, and worldwide. So these are the example of networks sizes. Once you are work from home, you are using the small office or home office. For personal use, you are using the small home networks. For the company, probably they're using a medium large. Example of these are the call centers and the BPOs. And for the wide or worldwide, probably these are the interconnected networks from the internet service provider or the search engine or the company like Facebook and Google, Microsoft. Or they have lots of servers around the world. LAN and WANs. So what are the local area networks and wide area networks? So once we are talking about local area networks, we are referring to small geographic area. While the wide area network, we are talking about the large geographic area. So example of this, if you are working with home or using your computer browsing through internet, they are interconnected through an internet service provider. This is the one, or wide area network. You can communicate your office home computer to your branch and central computer. Next, LAN and WAN. What are the differences? LAN is interconnect end devices in a limited area, while the WAN interconnect the LANs over a wide geographic area. So I already said before, the previous. So administered by a single organization, typically administered by one or more service provider for the WAN. For the LAN, provide high-speed bandwidth to internal device, while on the WAN, typically provide lower speed links between LAN device. Internet. You are using internet right now. So you cannot, reading materials that I already uploaded and video. So using the internet, you can download, browse through internet. So internet is a worldwide collection of interconnected LANs and WANs. So example of this, if you are chatting your friends, your connection probably you're using the Globe Telecoms and the other one is using the Smart Telecoms or the Globe Telecoms. They are the internet, two different internet service provider, but you can communicate with each other. So internet is not owned by individual or group. The following groups were developed to help maintain the structure, the internet. So we have the IETF, the ICANN, and IAB. So what are intranet? So intranet is a private collection of LANs and WANs internal to an organization that is meant to be accessible only to the organization members or other with authorization. So those are private LANs owned by a institution or a organization. So example of these are our campus information system, wherein you can only access that on your company or organization. Internet connections. I forgot to tell you, the other one is extranet. So what are the extranet? So an organization might use an extranet to provide secure access to their network for individuals who work for a different organization that need to access their data on their network. So example of this extranet are your suppliers, customers, and collaborators, where they can access your network, or they can communicate with your network or make a transaction to your network. Using your network, you're giving them an access. That is an extranet. So to sum up, if you are using intranet, that is for your employee. If you are on a company, those employees who can access your local file server, web server, or any repository server that is intended for the employee, that is intranet. Whereas the extranet is your clients and customer accessing your network. So that is a difference between intranet and extranet. Internet connection, internet access technologies. So most of you are familiar here. What are these? We have the broadband cable. We have the Converged ICT, where they cater cable TV and cable internet here in the Philippines. Another is broadband digital subscriber line, or DSL. So an example of these are PLDT My DSL. About the wireless LAN, or wireless WANs, and mobile devices. So example of wireless WANs, probably you've heard the Globe WiMAX before. Yeah, they provide internet connections. Another is mobile services, your smartphone, wherein you can use your mobile data to communicate or to browse internet. Organization need passive connection to support IP phones, video conferencing, and data storage. Why? It requires a quality of service. Business class interconnection are usually provided by service provider and may include business DSL, lease lines, and Metro Ethernet. So those are the internet access technologies. Home and small office internet connection. So probably you're now using your home network. So what are the connection needed for you to access internet? Probably you have subscribed on cable, like cable TV with cable internet offered by the Converged ICT. DSL, most of the DSL are with telephone lines. They are high bandwidth, always on internet connection, and runs over a telephone line. Yeah. Cellular, using your 3G, 4G, 5G SIM, you can access internet through your mobile data. Satellite transmission, usually this will be deployed on the rural areas where no cell sites, and you are using the satellite through Earth orbital. Another is dial-up telephone. Probably the dial-up telephone is already phased out because the bandwidth for this is 56 kbps. It's too slow. So business internet connection. If you are commercial, probably you want to interconnect your network through dedicated lease line, either NET1, DSL, and satellite. So what are the dedicated lease lines? So these are the reserved circuits within the service provider network that connect distance office with private voice and or data networking. Either NET1s, these are extend LAN access technology into the WAN. And DSL,
We have a business DSL, so we're already familiar with that. So if you are using this interconnection or internet connection, there will be a static IP address dedicated for your business connection. Converging network. So what is converge? So once they are already interconnected through your network, that is converged. So before converged networks, an organization would have separately cabled for telephone, video, and data. Each of these networks would use different technologies to carry the signal. So each technology will be used to different set of rules and standard. Example of this, if you're using your device or a computer to another computer interconnected, probably the data transmission will be using wired to wireless with different technologies used. Probably the other one is using cable internet, the other one is using the DSL. Ayan. Another is a telephone network. What are these? Example, you are using PLDT telephone connected to a globe telephone. Yan. How about this? Broadcast network using your television. So we have different channels transmitting and broadcasting through radio frequency that will be received by your television. So you are just tuning to the channel or the frequency. So once we are converged, sabi niya rito, converged data network carry multiple devices on one link, including data, voice, and video. So there are different information transmitted through your wired or wireless. So probably this is a data, voice, or video received by your host device or your computer. Reliable network. So we have here a network architecture. A network architecture refers to the technologies that support information that moves data across network. We have here 4 characteristics. We have the fault tolerance, scalability, security, and quality of service. So what are the differences? So once we are these 4 are achieved, we have a reliable network. The fault tolerance, example of these are if you're having a disruption of service, so there will be a mechanism that still you are interconnected. The scalability is the expansion of your network. Security, of course, we are with Data Privacy Act. We are referring for the security of all the information and data, even though this is a files, pictures on your repository. So, and authorized persons only who have access should or must access that information. So the quality of service, example, these are your the data transmission over voice. So there is a percentage required for the receiving. Example, these are your IP phone. Your IP phone that is connected through your local area network. There should be a dedicated bandwidth for that. So what is the fault tolerance? I already summarized it before. So a fault tolerant network limits the impact of the failure by limiting the number of affected devices. Another, scalability, or can expand quickly and easily to support new users and applications. So what other examples? If you are using wired networks, to another wired networks. You can add another wired networks. You can also add wireless networks if you want to. So the addressing scheme or the network address is expanding, as well as your network devices and host device. So quality of service. So voice and live video transmission required high expectation for those devices being delivered. Or as I mentioned before, the primary mechanism used to ensure the reliable delivery of content for all users. So example of these are IP phones. Why IP phones are critical? Voice transferred to another IP phone does not require delay. So it should be cleared. No choppy voice. Network security. We are talking with the firewall or the access control list. So the two main types of network security must address network infrastructure security. So free from hacking, probably. You need to hire persons or professional for testing network penetrations. Another is physical security. Once your computer handheld portables was lost, so that will be a problem to an institution, or how much it will cost. Preventing unauthorized access to the device. So we have a secure facility. So we are limiting the personnel who can access those devices. Information security with the Data Privacy Act right now. Information security. Your personal information must not leak to be used by the hackers examples. Protection for information or data transmit over the network. So once you are transmitting a data or information or file through a network, the data should not be hacked or it will not be catched by the intruders. The three goals of network security are confidentiality, integrity, and availability. The CIA. Network trends. What are the trends right now? Right now, you're using your smartphone, laptops because of the pandemic. So we cannot use the school laboratory right now, the computer laboratory. So you are now bringing your work from home. So bring your own device. You're not using your device to access these resources for your studies. Online collaboration, we'll be using what are the example of online collaboration? Example of these are the Cisco WebEx, the what do you call this? Skype, Zoom. That are the example of online collaboration. Or using our Cisco Net Account sites and Edmodo, we can interact using these websites. And video communications, probably most of you have a TikTok. You are TikTokers. So you are uploading your videos from different streaming sites and sharing with your friends through Facebook. And video communication. Or example, this if your parents is working abroad and you need to contact to share your thoughts. And you are using video communication. Either you're using your Facebook Messenger for video, or you're using the Skype, or you're using the different apps available Uh, Another is cloud computing. What are cloud computing? For as long as you're saving your file through internet, the internet will be your repository uh, for your files and data. Example, these are your pictures. You want to keep it because they are precious memories. Probably you'll be uploading it through your Facebook, your Instagram, or your Twitter. Mm. Or you can simply save your files through your Dropbox or Google Drive. Yeah. Or save the greatest memories. So bring your own device. Probably you're now using your smartphone, laptops, or desktops. So those are examples of your personal device. Next, online collaboration. These are example. We can communicate to each other using the Cisco WebEx. We have also the Google Microsoft Team example of this. Video communications, video conferencing, either Skype or Zoom, and, or the Cisco WebEx. You can also use that for video communication. Facebook Messenger, and Cisco WebEx. So probably we will be using Cisco WebEx for our synchronous discussions for those who have queries. So we will make sure that we are online soon. Cloud computing. We are using the repository for your personal files or backup data to online servers. We have four types of clouds. We have public clouds, private clouds, hybrid clouds, and custom clouds. So what are these? Available or the public clouds available to general public through pay-per-use model or for free. Example of these are your Google Drive. So I think the Google Drive can offer 10 gig or 20 gig of this space for you using your cloud. But if you want to expand, there will be a subscription fee for that. Private clouds intended for specific organization or entities such as the government. So for government use, example of these are the information you can get on the .gov.ph or gov.ph sites. Hybrid clouds made up of two or more cloud types, example, the part custom and a part public. So these are personalized probably. So each part remains distinctive object, but both are connected using the same architecture. Hybrid. Custom clouds, customized, or built to meet the needs of a specific country. So you have a specific business, you might create a custom clouds that is intended for your business. So those are the example of clouds. So technology trends in the home. Well, what are available technologies in your home? Well, probably you have your home is equipped with Internet of Things like smart house. If your house is there's a burglar alarm, probably your house might text you, or your car has been stowed. The car, you can trace your car using the GPS, or even your smartphone. You can trace nowadays your smartphone. Power line networking. So what are power line networking? So power line networkings can allow device to connect to a local area network where data network cables or wireless communication are not variable options. So you can interconnect your intermediary devices and your host devices to this power line network. So what, of course, they will provide a power needed by your device. Or using a standard power line adapter, the device can connect to a local area network wherever there is an electrical outlet by sending data or certain frequencies. So that's an example of the power line. Power line networking is especially useful when wireless access points that reach all other devices in home. Yan. You're using the access point or extended as a repeater, and where there's no available power line or power source. I mean, wireless broadband. So what are the wireless broadband? You're using your smartphone right now, and your SIM probably a 3G, 4G, or a 5G SIM or an LTE SIM. You can surf internet, or probably your mobile app can interconnect with the internet. Yan, using your mobile data. Network security. What is network security? We have security threats. So network security is an integral part of networking regardless of the size of the network. Usually, the operating systems already have a firewall, but we still install antivirus and anti-spyware to prevent those threats. Securing a network involves many protocols, technologies, device tools, and techniques and other to secure data and mitigate threats. You are also some of the network or small network, you might probably deploy an appliance firewall. Yan. Threats vectors might be external or internal. What are the external threats? Probably those are the gray hat and the black hat hacker attacking your computer. For internal threats, probably your employees. They might accidentally destroy your information or intendedly copy your information. Those are internal threats. That will be include the physical threats. If they stole your devices. External threats. External threats. Those are examples of virus, worms, and Trojan, which you're already aware. The spyware and adware, the zero-day attacks, threat actors, denial of service attack, or these are the bots or zombies. Data interception and theft, and identity theft. What are the identity theft? Those are the master of disguise or the social engineer, pretenders, the great pretenders. Internal threats, so your device might probably lost or stolen or accidentally misused by employees or malicious employees. Security solutions. So what will we do to escalate or to solve that problem? So probably we will install an antivirus and anti-spyware for those threats, for virus, worms, and Trojan. or we can deploy firewall for filtering and blocking unauthorized access for those hackers. Larger networks, what will they deploy? Probably deploy a dedicated firewall, access control list, intrusion prevention system, and virtual private networks. So that are the mitigation for the security of your network. So IT professionals, what can we get from studying Cisco working program? So we have a certification exams under CCNA. So we have a CCNA, Cisco certified CCNA or network associate. We have also a Cisco certified specialist, network professionals, and CCIE for the expert. New certifications are available. The DevNet certifications offered by the Cisco. So you can also look for a job. If you're finding a job, you can use your Cisco account to look for a job where Cisco have partners globally. Those who have job hunters. So for your packet tracer activity, please do the laboratory activity 2 later before I discuss the module or the chapter 2 for this module. Or what did I learn in this module? Or this is just a short discussion of what are the previous discussions. So we discussed your own device, different cables, different networks, the local area networks and wide area networks. Using your internet connection, you might use DSL, cellular, satellite, or dial-up connection. The company might use the dedicated list time through Internet and business satellite. The quality of service, security, fault tolerance, scalability, the BYOD, protecting your company from external and internal threats. You might deploy this antivirus, anti-spyware, firewall filtering, and others. And for the certification, so once you have finished the 3 module of the Cisco, the Cisco will give you a voucher for that. So to start, chapter 2, so basic switch and end devices. So we will be using the packet tracer in this segment. So for our objectives, so what are the objectives of this chapter 2? So explain how to access a Cisco Ios device for configuration purpose. Explain how to navigate Cisco iOS or Internet Working Operating System to configure network devices. Describe the command structure of Cisco iOS software. Configure a Cisco iOS device using command line interface. Use the iOS command to save the running configuration. Explain how device communicate across network media. Configure device with an IP address. Verify connectivity between 2 end devices. So let's start. The Cisco iOS access. So how can we access? So the operating system usually have a shell, kernel, and hardware. So what are shell? Probably your operating system is using command line interface or the graphical user interface. What are kernel? Kernel are the communication between hardware and software. Hardware is the physical part of the computer, including underlying electronics. Those are hardware. So the graphical user interface, so if you're using Windows 10, Windows 7, you are using the Linux, Ubuntu, or you're using your Mac OS. They are on the graphical user interface, a colorful environment or a user-friendly environment, wherein your command line interface or the CLI or window with a black and white environment. You are just typing the command using a text-based command. Ayan. That's the difference between the two. So you may access the intermediary devices like the Cisco switch or Cisco router using the Soul, Secure Shell, and Telnet. So I will demonstrate to you later how we can access those three examples of access methods using the tracer. We are using the terminal emulation in real life, configuring a Cisco router in which we are using the special software like PuTTY, TerraTerm, and Secure CRT. So software can be downloaded from the internet. So install and that will be used as a terminal emulator to communicate to your intermediary devices. iOS navigation. So these are the modes. Usually, once you are in a command line interface, you need to look for the symbol for the mode. Example of these are the user exec mode, a greater than symbol. If you are in the privilege mode, you are on a hashtag symbol. If you are in the global configuration mode, you have another config symbol here or words for line console and virtual terminal lines, and auxiliary lines. You have a config line. For the interface, what are the interface? These are your ports, your Ethernet ports or network interface port, where you can put your IP address. This is also includes the switch virtual interface. You're inside a config if mode. Later I will demonstrate those modes and how you can access that. So navigation, we have the privilege mode. So once you are in the user exec mode, you simply type enable for you to move on the next level, which is the privilege mode. For you to move to the global configuration mode, you need to type configure terminal. You type here configure terminal, then you will be moved to the global configuration mode. So using exit command, you are simply moving downwards, or you are moving a downward mode. You're escaping a mode. So that is escape using exit command. So you can also use the end command or the control C command. What is the difference between exit and end command? If you're using exit, you are just skipping one mode at the time. Wherein if you're using end button and Control C button, the iOS will direct you automatically on a privilege mode. Okay. So if you use end, you will go, the iOS will move on the privilege mode. Other commands you can use, enable, disable, configure terminal, exit, and Control C on your keyboard. So that's the previous command. How about the basic iOS command structure? We have here the keyword and arguments. So we have here the prompt. This is your command line interface mode. Then you will type the command. Example of this are show, then space, and this is the keyword. Because the show commands, there's a lot of command next to the show commands. So those are the arguments. iOS command syntax check. Once bold text indicates command and keywords that are entered as shown, or the italic text indicates an argument for which the user provides the value. Yeah. iOS command. So using the ping or the packet internet group command for you to test end-to-end connectivity from source to destination if they are interconnected. So you simply type ping, then IP address of your computer. Using traceroute, you can also test the hop count or the hopping of packets over a router interconnections. Yeah. From source to destination, hopping from router to router using the traceroute. You can also use the question mark. If you don't know the next command or the next argument that will be used, the iOS will prompt you the possible or possible command or argument that you would like to type. So example of this, ping. You ping, then question mark, then the iOS will provide you information, either a word, an IP, or an IPv6. Yan. For the caret, what is the symbol of caret? This one, the caret sign, it shows you the mistake or the if the you type is invalid, where probably it requires you to interface pass either NET1 or probably the space. No. You are in a global privilege mode and you are typing an interface pass Ethernet where this command should be available in a global configuration mode. So this interface command is not available for this mode. Yan. Video. I will demonstrate to you later. Hotkeys and shortcuts. You can use mnemonic commands on Cisco Ios. Later, I will demonstrate to you what are the mnemonic commands or the short end commands that you can type. Those commands are acknowledged by the Cisco Ios. Example of this, there's an ambiguous command because you are typing con. There are two commands available in the Cisco Ios. There is a configure and connect. So the iOS is confused. Which of the two are you referring to? I will demonstrate that later. Using the tab, backspace, left arrow or control B, right arrow or control F, and up arrow and control P. So just read the description for the tab. It will complete you the partial command, backspace for deleting character to left. Move the cursor up character to the left for control B, and right naman using control F. You're just using the left and right arrow key, just moving for the moving text command. Another is enter key, spacebar, and other keys. So, control C, this is also important if you are trying to cancel the command, or control shift 6. Yeah, this is most of important command if there is an ambiguous or a word translating inside the configuration. Once you mistake, there you have a mistake commands. Yeah, they are useful. Next, this is just the recap of all discussed. The tab, shortening, control C, control Z, control shift 6, and control R. I will demonstrate to you later the packet tracer. Wait for it. Device name, like your computer, you have a computer name. So the same with the switch and Cisco router. So they have a default name switch for the router, the capital R, router. That will be the default router name. So for you to change the switch or router name, simply use the host command. So once you are in a global configuration mode, simply type host name, then the name of your switch. So once you have entered or pressed the carriage return, the host name of your switch will be changed. For you to go back or to return to each original host name, simply type no host name on your global configuration mode, and it will return to the original state command. Password. Of course, you don't want somebody to access your router and your switch. So it requires a password. So guidelines for password. Probably most of you need at least minimum of 8 characters, combination of uppercase and lowercase with numbers, and you can also use dash character. Avoid using same word for all devices. Another is do not use common word because they are easily guessed. So you already learned from your IT Essential course. Password should be or must be like Jejimon. You can test its strength. Yan. How to configure a password. So using your line or console line, simply key in line console 0, then type your password, then type login and end. I will demonstrate that later. For the privilege, just key in enable secret, then this is your password. You can also use the enable password here instead of secret password. There is a difference between two. For virtual terminal lines, so we have a line BTY 015. That means from 0 to 15, we have a 16 simultaneous user that can access to your switch with a password Cisco once they log in. Yeah. Service password does encryption. So you can type key in this for on your global configuration to encrypt your password. I will demonstrate that later. Banner, this is just a message of the day. So banner mod D or the message of the day, then the message would like to be seen by the console and the telnet user or SSH users using the virtual terminal lines. Video. Save configuration. How to save your configuration? So to save your configuration, you might want to see the show startup config. So this is the once you reboot your switch, so the switch will read the startup configuration. So once you are changing any configuration, it will be on the running configurations. So if you reboot your switch without saving those new configurations you created, the default once you restart your switch, it will automatically read the startup, which is your default configurations. All the configurations made from the running configurations will be lost. So to save your configuration, so simply type copy running config to start up config from source to destination. So that will save from RAM because the running config is on the RAM and the startup config is on the NVRAM or non-volatile RAM. So RAM, as you know, RAM, once there's no power on the RAM, the configuration will be lost. So to save the configuration, you need to save it on the non-volatile RAM or NVRAM. So running configuration, if you want to boot your router or your switch, simply key in the command reload. This is just a soft boot. If you are repairing to hard boot, we are turning off using a power by removing the power source or turn off using the switch, power switch. So on your operating system, you just click on restart. This is the command for restarting the reload. To delete the configuration on your startup configuration, you simply key in the command erase startup config, then reload. Automatically, all the startup configuration will be erased, so it will return to the factory setting. Using the command, the PATI or the PuTi or the virtual terminal emulator to interconnect through configuration your switch or router. Capture, what's this? Show running config. If you want to capture, we have on your PATI, we have the session logging. Ports and addresses. On your computer, personal computer or smartphone, you can statically put your IP address or input your IP address. You already learned that from your IT Essential course. you can put your IPv4 and IPv6 address on your computer. I will demonstrate that later on using the packet tracer on how to place a IP address on your end devices. So interfaces and ports. So as you can see, the Cisco has a product that we have a switch with multiple ports, either fast Ethernet or gigabit port. Yeah. It also supports what media, technological media will be used. Either you will use an RJ45 for the copper wire or the fiber optic lines. Yeah. Mhm. Configure an IP addressing. So on your IT Essential course, you already know this. And you just simply go to your network connections and place the IP address on your local area connections on your pass on your Ethernet or your network interface card. Uh, if you're using Obtain, therefore, probably your computer is interconnected with the router or a DHCP router that broadcasts a router IP address. It That means that the DHCP router will be lending an IP address for your computer. It's a leasing. For the managed switch, so we have a switch virtual interface or SVI. The switch has no ports for IP. So we are using the virtual interface because this is a managed switch. So that we can remotely manage the configuration of the Cisco switch. So to place an IP address, simply key in the keyword interface, then VLAN1, this is the default, then place the IP address. This is your IP address and the subnet mask. And to turn on that, to enable or turn on that interface app, you need the command no shutdown because the default is shut down. Using packet tracer. Verify connectivity. Usually we are using the ping command for verification. Test and connectivity. Quiz. So what we have learned from this segment. So you've learned the operating system. We have a different modes. We have the user exec mode, privilege mode. We have the global configuration mode, interface mode, and line mode. To place password, host name, and encrypt, and using the banner or the message of the day. So we need to save the configuration using your startup and running config. So let me post that discussion. So let's move on the demonstration. So using packet tracer, so you can download your packet tracer on your Cisco account. We will be using the packet tracer version 3.0. No? So to know about your packet tracer version, simply click help, type about. You will see the version of your packet tracer here. Let's demonstrate. So example, you have a computer, you have a desktop computer, and you have a switch, and that is a symbol of router. Example, we have a 2960 switch. Yeah. And we need another computer here. There you go. How about placing a router? Okay. On your IT Essential course, We have a different cable or UTP cable demonstrate. You have a straight through cable, crossover cable, and a rollover cable. So to configure the switch, we need a console cable. So we simply click the lightning symbol on your packet tracer. Click in the console. You can see on your lower or the bottom what cable you are selecting. So if you click here, you will see a word console. So simply connect the console from your RS232. It means your serial port or your computer serial port. Then the destination will be your console port. So this will be your console computer. So let me write here. This is your console computer or console PC. Next, this is your switch. Switch, let's connect switch pass Ethernet 1 to your local computer PC2 using the pass Ethernet cable. Okay, you've learned from your IT Essential that switch to PC will be using a straight through cable. If you are using switch to switch, example, we have another switch. I put it here, another switch. Switch to switch, we are using crossover cable because they are uh, unlike devices. For unlike devices, we will be using straight through cable. So from router to your computer, router to switch, that will be a straight through cable. Example, gigabit to gigabit. You can see a symbol red because that interface of this router is not yet up or it is by default turned off. Okay. So how we will be configure this switch? So let's say that I want to place, I want this switch to have an IP address of, let's say the IP address of switch is 192.168.21.2 with a subnet mask of 192.168.1 that mask mistake. Subnet mask 255.255.255.0. That is a network 0. Okay. Next, about this computer. I want this PC to have an IP address of 192.168.0.3 with a subnet mask of 192.255.255.255.0. So this is your switch virtual interface. Okay. Yeah. This is for your switch. Okay. Switch virtual interface. Okay. What if this managed switch, I want you to have the requirements example under your console password example, your console password will be kunyari, example console password is password console. For your virtual terminal line password, I want your password to be massbty. For your privilege password, I want your password to be a pass secret. Example. Yeah. Another requirement is for your secure shell password, because there is a secure shell demonstration. I want you to place your secure shell password is mass SSH. So, yeah. Oh, how about a message of the day? I want you to place a banner that unauthorized personnel keep out. Example only. Yeah. Oh, we have forgot that this using the secure shell, it requires domain. Example is mcc.edu.ph and requires an administrative password for a user. Example is admin. Okay, so let's demonstrate these requirements. So you've learned how to place a end devices and a intermediary devices. Well, in this topic, we will focus on the switch. So let's remove the router because there is another discussion for the router, separate discussion for the router. So in chapter 2, we'll be using the Cisco switch. So to configure the switch, the console does not require an IP address, okay, because there is no direct link from the pass Ethernet here to your switch. We are just simply using the terminal emulator line or the console cable to configure the switch. Uh, let's test how to configure a managed switch using your computer or desktop computer. So simply click the switch. Oh, if you want to see this desktop computer, we have here turn on, turn off button. Okay, simply go to desktop, click the terminal, then click OK. So you are now inside the terminal emulator line. So that means that the computer or the PC0 now can configure the switch. Okay. There, you are now inside the switch iOS. Oh. So before, on our previous discussion, I already told the use of question mark if you don't know what commands are available per mode. So using the question mark, yeah, you see the question mark, it will allows the iOS to display all the available commands for this user exec mode. So we need to type enable to move to the next mode. So enable, okay. Then you need to press question mark again. Okay. You can see the word more here. So by typing enter, you can view all the next list of commands that are available. If you want to cancel that, simply click Control C for you to end those listing command available. So previously, I told you that how we will determine, you can use the mnemonic command. So if you can see, we have two command here, configure and connect. Both there starts with con. What if I want to go to global configuration mode? I want to go to global configuration mode. Oh, by the way, I want you to see what is the initial configuration of switch before we move on to the global. So simply click on run. If you're typing the command, example config, you have a long command typing the running config. Show running config, it will display you the initial configuration of switch. So the initial configuration of switch is the default host of switch. To pass Ethernet, we have a port 1 until port 24 and 2 ports available. As you can see, the switch virtual interface, there's no IP address, and by default it is shut down. The configuration command for console and virtual terminal lines are not yet placed. So another command that you can use, or the shortcut command that I told you before, is if you're typing show, example, you're typing running again, run, you can use the tab to complete the command. Okay, using tab. That is also the same. Press Ctrl C to go back to terminate the viewing. Next, I want to type, or I want to move on the global configuration. So simply key in configure. Example, I type configure. Remember, there is con. You can also type question mark if you don't know the next command. So using the question mark, the iOS will prompt you. There will be a two choice. Either you use the configure or connect. What if I did not select or key in the two keywords that I need to uh, key in? So let's say configure, then I type terminal. I want to go to global configuration. Oop, ambiguous command, because there is a two available word. So what about configure I simply type configure uh, configure. Mhm. What I'm telling is it possible that I can use mnemonic or partial command? Yes. Using the word configure is here, since there are two, configure and connect, double N, and this is F. So it does not require me to type the whole command. So simply, I just want a mnemonic command or a partial command of configure terminal. You don't know the next command, question mark. There is only one another command available here. Should Can I use configure terminal in conf ft? Yes, because there's only one option here available for the keyword or the argument word. Yeah. We are now on a next level, which is the global configuration command. So let's key in our requirement or our packet tracer requirement. Uh, the requirement is I want you to place an IP address for the switch virtual interface. So simply key in interface using tab VLAN 1. Then let's place an IP address. IP address. You can click the tab if you want to. Then let's put the IP address of the switch 192.168.1.2 with a subnet mask of 255.255.255.0. Okay. And this is our switch virtual interface. Enter. Then we will turn on the interface by placing no shutdown. Enter. As you can see, the virtual interface 1 changed state to up. So here, the interface now has an IP address. Oh, before I told you if we can use the exit and end command. So what is exit? So if I key in exit here, I am simply moving a mode downward, or we are just reducing the modes. So if I want to go back, interface VLAN 1, what about end? Typing end will move you in the privilege mode. Okay, end. You are now in the privilege mode. I want to see if the IP address is now active in the configuration command. So I simply type show running config command. As you can see, the host name is still a switch, like we typed before. And look on the last part. There we go. You can see here that we already configured the virtual interface of the switch or the managed switch. How about if we want to change? How about I want to click type the show? What are the other show commands that available? You can now show access list, show ARP, show crypto, show clock. Oh, you have a clock here. Those are the MAC address. This is important. Okay. Show. How about show clock? Oh, the default switch clock and date was configured on March 1, 1993. And you want to change that system time and system date. So to change that, we have a command clock. If you don't know the next command, click the question mark. You have the word set. You don't know the next command, key in the hour, minute, times, seconds. So it's already 9:54. So let's type 9:54:00. We are using the military time. Okay. Next command. You don't know. We have the month, day, year. So we have a what's today? 23. Don't know the word. The word month. You simply write the month, then the year. 2020. Enter. You will see CR or a carriage return. That means press enter key. Oh, you have now changed the system time. So before, that is March 1993. If we type now the show clock, we've already changed the clock from 1993 to 2020. Okay, let's change the host name. So we type configure terminal. So let's change the host name of the switch. Let's say the new name of the switch is switch 1. From your host name become a switch 1. Previously on the PowerPoint presentation, if we key in the no host name, what will happen? It will return to the default switch name. Using the up key, you can see your previous key in command. So up key. So I want to change it to S1 for the name of your switch. So next requirement, let's create a console. That means the password for this computer, once we are interconnected here, requires a password. So let's demonstrate. Line console 0. Then password. What's the requirement password? Pass console. Then type login. Okay. So what are the impact of this? So let's type end. We are on the privilege mode. We type exit. There we go. So this console computer requires a password now to this managed switch. So key in. You cannot see what are you typing. You type pass console. There's no asterisk here. You cannot see it. That is one of the goodness of the Cisco. Your type, the other personnel cannot see how many characters you are typing. So we're now on a user exec mode. So let's type enable, configure terminal to go back. How can I view the running config in a global configuration command? Let's say I want to type show running dash config. There is the symbol of caret symbol here because this command is available only in a privilege mode. So what if I want to execute this command in a global configuration command that available in a privilege mode? So simply press up arrow key. This is our previous one. Simply key in, add the word do, then enter. Oh, there we go. You can see now the host name has been changed. And on the last part, you can see the virtual interface and the console. Oh, look at the console. You can visibly see the word pass console. Next, how can we ensure that that password is not visible to the user? So we need to key in the service password. Let's type the tab service password dash encryption. So what will be the impact of this command on your configuration command? Let's go back to the do show running config. Previously, you can see here the password console. Now, using this command, uh, we are moving on the downward. Okay, you cannot read now because it's already encrypted. The password is already encrypted. Okay, there we go. How about if we want a banner? How about banner? What is banner? Banner, message of the day. You need to place hashtag. It requires you to place another hashtag here. So you need to place your message in between this. Okay. What if I press enter? Oh, as long as you are not ending with the hashtag, it will not close. Okay. Let's put some message. The message is unauthorized personnel. Unauthorized personnel. Keep out. Example. Then we press hashtag again. Okay, what are the impact of this command? So the impact of this command, if we key in the end, exit again, enter, you will now see the banner message of the day. Then it will prompt you to the password of console. Okay, so let's key in the password, pass console, enter. We are now on the console again. Enable, configure terminal. We'll back on the configure terminal. So how about the virtual terminal line password? So what are the function of virtual terminal password? So let's go to line BTY015. This means that we are having from 0 to 15, there could be a 16 simultaneous user that can access your console or your managed switch. So we are on the line mode. I want to place a password. Password pass BTY. There you go. Click login. Enter. Okay. Type exit. So what is the function of this password? So let's to the show run command if we want to see if we successfully place and password for virtual lines. There we go. You have a password for your virtual terminal lines. Okay. So what are the function or the purpose of that command? So if you have a computer, the PC1 is trying to configure the switch other than console computer, we can simply connect to that managed computer. First, we need to place an IP address for the computer. So the IP address of this computer is 192.168.0.3 with 255.255.0 as your subnet mask. Okay. Again, next, using your command prompt. We are now on the command prompt. I want to, or let's use ping. I want to test if the computer PC1 can communicate to the to the switch virtual interface. So ping, the IP address of the switch is 192.168.1.2. 1.2. There is a mistake here. What? They are not the same network address. 192.168.1, 192.168.0. So there is a mistake. So you need to change the IP address of your computer. So let's correct the IP. It's now 192.168.1.3. This is 1.3 so that they are on the same network address. Since we are no the same network address, can I ping now? Okay. Timeout, reply. Why there is a first timeout here? So the first timeout because the switch does not have the MAC address table, or it requires the switch to create a MAC address table. Okay. Once you are typing the ping again, there will be a reply. That is just for initialization of switch to create a MAC address table. Okay. So how is that? If this, let's go back to the switch. Let's type exit here, and I key in show MAC address table. There you go. We are on the pass Ethernet 02. Is this a pass Ethernet 02? Let's show it on your preferences. I want to view the cable. Show port table. How about this? Yeah, you can see now the pass Ethernet 01. So let's go back to your switch. Where is it? Switch. Oh, the PC here. Oh, terminal. Okay, there. You can see on the pass Ethernet 01, this one, we have a MAC address of your computer here. How do the switch knows that? If you click the computer, I key in IP config here. Yes, IP config. /all, I can see now that this computer MAC address, we look for the physical address, IP address, there we go. We have a physical address up here. So showing on the table, why is it the physical? No, this one is your physical address. There, they are the same. So that is the purpose of the first request timeout, because the switch will broadcast. We'll use the broadcast to collect the MAC address interconnected on the switch port. So next, how will previously we key in the virtual terminal lines. So how to connect that? We will now connect to the switch using telnet command, then IP address of your switch 1.2. Okay, that will prompt you the banner message of the day. Remember, this PC now can configure the manage switch here. Okay, we have the password. What is the password? Is it the password console or the passbty? We will be using the passbty. Passbty. Enter. You're now inside the switch remote or manage switch. Okay, you can now type enable. Oh, enable. Oh, there is no password set. Okay, why there is no password set here? We have not yet configured the privileged password here. So that's a good point. So let's make a password for the terminal. Let's create a password for privileged password. So how we will do that? So key in enable secret. The password is pass secret. Enable. Okay. So is it possible for the switch one now can connect? Yes. Let's type enable. Oh, there is a password now. Pass secret. Enter. Oh, there we go. We can now on a privilege. You see, console computer can configure the managed switch, as well as the PC can now uh, configure the managed switch. Okay, let's move on the next. Okay, let's terminate the command. Next, how about the secure shell? So, let's configure the secure shell. So we don't want the telnet and secure shell. Okay, we will add the secure shell. To create a secure shell, it requires a domain name. So to add a domain name, the command is IP domain-name. Then we place the mcc.edu.ph site. We have already created the domain. Next, we need to create a crypto key. crypto key generate okay, tab RSA. There you go. So the default is 512 for the bits modulus. So what if I want, let's create a modulus here. Modulus requirement of 1024 bits example. I want to type 1024. Okay, we're now creating a 1024 bits RSA key. So to create a user, you need to key in the username. The username is admin. Then you have a choice, either you use password or secret. I used to use the secret command. Then the password will be pass SSH sample. Now we have now enabled the secure shell. So to enable that on the switch virtual interface, we need to move on the line virtual terminal line 015 or 04 if you want, for making a simultaneous user 015. What I want now is the user requires to connect to the managed switch, either SSH or telnet. If you don't know the command, that's all. You can key in SSH or telnet or all. I want to use SSH. If you want telnet, on the actual switch, you can use comma. I don't know on the packet tracer if it will allow the comma, or it does not allow the comma. It just requires you to select one. But if you're using the switch, you can use comma. Okay, then since we have already created a local user, the admin, on the switch, we need to create a login local command. So what are the implications of this command to the managed switch? So let's connect again. If using telnet, we are now unable to connect to telnet. Why? Because we require the switch virtual interface to create a connection only for SSH. So we cannot use now the telnet command. So key in SSH for the user to connect to the SSH, to the remote managed switch. Key in SSH if you don't know the command, question mark, or we are on the PC. That is the syntax we need to achieve. SSH dash L, a local user, then a local username. The username we've created is admin. Then the IP address, which is the target, 192.168.1.2. So the password be pass SSH. Okay, there we go. Using the secure shell, we can now connect the PC to the managed switch. So what are the difference of telnet and secure shell? Okay, the telnet are the text for the password are viewable for the hackers. So we don't want that to be traced by the hackers. That's why we are using secure shell. So secure shell is most secure than using telnet connections. So there you have it. So you can now do the configuration for your packet tracer activity under the module 7 packet module 7. I told you that you will be having a take-home laboratory activity. So you can do now the packet tracer for the chapter 2, which is configure initial switch setting, implementing basics connectivity, and switch and device configurations. Okay, let's move on to the last part of this discussion. Chapter 3. Chapter 3, what are the objectives? So describe the types of rules that are necessary to successfully communicate. So explain why protocols are necessary in network communication. Explain the purpose of adhering to a protocol suite. Explain the role of standards organization in establishing protocols for network interoperability. Another is explain how the TCP/IP model and the OSI model are used to facilitate standardization in communication process. Explain how the data encapsulation allows data to be transported across the network. Explain how local hosts access local resource on a network. So let's start. What are the rules or the set of rules or the protocols? So you can serve more videos using your Cisco account, as I told you before. So rules, communication fundamentals, there should be a sender, receiver, and a media. Like humans, if we are sending a conventional mail, it requires a sender from, then the destination to, from to, then the mail itself or the media. How will I send the mail? The conventional mail using the local mail post. Or how about if you're using an email or electronic mail? So your source will be your email account. Your destination will be the recipient email account. And the channel will be the intermediary connection between the two servers. Example, you're using the SMTP, Simple Mail Transfer Protocol, for the Google Mail to Yahoo Mail. From your Google Mail will be placed on the sent, and the Yahoo Mail will be placed in the recipient inbox. So the media will be used, either we use the wired or the wireless transmission over the internet. So communication protocols, all communication are governed by protocols, because protocols is a set of rules. So protocol are the rules of the communication will allow. These rules will vary depending on the protocol. So example of this, we have a message, signal transmitter, transmission medium, signal delivered, receiver, and a message destination. So the same as human, as we communicate with each other, if you know the language of Kapampangan, then if you are Ilocano and you're talking to Kapampangan, the protocol, they will not know, or they don't know what the words they are saying, because they are not talking to the same language. But if a person knows a Kapampangan or Ilocano, or he's a multilingual, or he can interpret those messages what are the persons trying to tell. Or as a human, we are also using the gestures, or just simply clicking the eyes like that, or winking, or we just placing your hands. You're placing a thumb like that. It means okay, but it's not okay if you're probably on Malaysia, because using the forefinger for buying things is prohibited. You need to use the thumb if you are using, or if you want to buy. There's rules for every governing protocol. So rule established. So individual must use established rules or agreement to govern the conversation. So first, message is difficult to read because it's not formatted properly. The second shows the message properly formatted. As you can see here, there are two different letters. Protocol must account for the following requirements. Identify the sender and receiver, that is prompt, and two, common language and the grammar. So what are the language they are using for them to translate? Then speed and timing of delivery. Then confirmation or acknowledge and requirements. So those are the requirements. Network protocol requirements: message coding, formatting, and encapsulation, the size, timing, and delivery option. So I will demonstrate that using the Wireshark later. So there is a requirement: size for transferring frames, example. Message encoding. So encoding is a process of converting information to another acceptable transmission. It's just like a encapsulation process. Okay, encoding and decoding. The reverse this process to interpret the information. Okay. Next, message formatting and encapsulations. So we have here an example of a mail. So we have a sender, this is from, and the destination, the recipient is to. So it requires a format. Another is the message format depends on the type of message and channel that is used to deliver a message. So this is an example. For the computer to transfer information, it requires source IP address, destination IP address, source MAC address, and destination MAC address. Okay. I will demonstrate that later on using the Wireshark. Message size. So we need to standardize the format of the size, because if the message is bulk, we need to chop, or we need to create a bits or a chunk, or the word chunk, the chunk of messages for the recipient computer to receive them all. It's like a games, what they call, a puzzle game, wherein you have a you need to complete all the pieces in order for you to view all the message. Okay, it's like a whole sheet of paper, then put on the shredder, and each pieces of shredded paper was given to you, and it requires you to create a tape for you to read all those chunk messages. Timing. So we have a flow control, a response timeout, and access method. So flow control manages the rate of data transmission and define how information can be sent and speed at which is it can be delivered. So usually the flow control create a rate of data transmission in terms of probably of bandwidth or good put, throughput, or the response timeout, manage how long the device waits. So there is a requirement acknowledgement because the communication using computer, we have the UDP and TCP. It requires the end party to acknowledge those what all the recipient received. Okay. Access method determines when someone can send a message. If there is a chunk of message that been discarded, it requires to the from the source to retransmit it again. So because of the collision, what are collisions? These are the garbled message. Probably there is a two computer transmit at the same time on a physical connection like electrical pulse using the UTP and STP, and the two transmitted information collide. Well, there will be a garbled message. So that message will be received by the recipient. It will be discarded. So it requires again for the recipient and for the source to retransmit the discard message. Message delivery options, you have the unicast, multicast, and broadcast. Once we are using unicast or 1:1 communication, we are simply telling that there is only two party communicating each other. Example of these are your televisions, the TV broadcasting network transmitting radio frequency signals for you to view it on your televisions. That is a unicast. How about multicast? So multicast is one to many or typically not at all. There is a selective group that can receive a specific message. Okay, example on your class, you have grouped into 5. So those per group, if there is a message relayed on them, those groups only receive the message. Not all the groups will receive that message. That is a multicast. But for the broadcast, all of those groups or individual will receive the message. Okay. This is an example of unicast, multicast, and broadcast as a illustration. Okay. Protocol is a set of rules can be implemented on a device, either hardware, software, or both. Another is the function, format, and rules. So these are the protocol type: network communications, network security, routing, and service discovery. Okay. Network communication enable two or more devices to communicate over one or more networks. So this is the interconnection of devices. Security, secure data to provide authentication, data integrity, and data encryption. We are preparing for the security of the informations transferred from source to destination. Okay. Routing enables the router to exchange route information to compare path information and select best path, because the router is the one judging where to forward your packet. They are relying on the metric cost. Okay. For example, there are 3 routers interconnected. That the first 2 router bandwidth is 1 Mbps. The second router is 2 Mbps, and the last router is 10 Mbps. Where should the router forward the packet? Of course, it will choose the best path, which is the 10 Mbps, to forward that packet so that it will be deliberately timely on the recipient. So that's one purpose of the routing. Service discovery used for the automatic detection of device or services. So those are the discovery protocol. Example of these are the Cisco discovery protocol of the router and the switch. Okay. It's just making the intermediary device to be discoverable by the client or can be viewed by other intermediary devices. Network protocol functions. So the device used to agreed upon protocols to communicate. So there will be a agreement between two parties or more parties. Protocol may have one or function addressing reliability, flow control, sequence, error detection, and application interface. So addressing identifies the server and receiver. Probably this is your IP address, source IP, destination IP, source MAC address, destination MAC address. Reliability provides the guarantee of delivery. Is the bandwidth is reliable, or is there's a what do you call this, throughput and the good put, or is there a latency? That should be eliminated on the reliability because it requires the guaranteed or the recipient guaranteed to be that the message will be delivered. Flow control ensures the data flow at the efficient rate. So example of this flow control are if the data transmitted from the source to destination, there will be a chunks of messages, and those chunks are transported with a guaranteed bandwidth. Next, sequencing, or uniquely label each transmitted segments of data. So the segments of data is like a chunk. Example, you have a message of one message, then it was equally divided into 5. So there is a 1-5, 2-5, 3-5, 4-5, 5-5. So that chunk of message will be delivered into the recipient. Then the recipient will, like a jigsaw puzzle, it will make those chunk into a whole so that it can be read by the recipient. Error detection. So determines if the data become corrupted during transmission. So there will be a detection if the received frames or packet from the recipient should be discarded, or it already redundant frames. Oh no, because it's already received. So it's just receiving a chunk of messages and packing to make it a whole message. Application interface, so the process to process communication between network applications. So what are the application interface? So this is the process of communications. What are example of the process of communication? Maybe this is an example of from wired to wireless communication. If you're using laptop, you are interconnected with the wireless, then to the other computer is using wired. So there is a two. This is the carrier sense multiple access over collision avoidance, and carrier access for collision detection for the other one. Protocol interactions. Network required to use several protocols. So each protocol has its own function and format. Example of these are the HTTP if you're using a browser to browse internet. Example of these are the HTML, PHP file. Oh, those are on the HTTP. Transmission control protocol. So usually on the transmission control protocol, there are port address. Internet protocol delivers the message globally from sender to receiver. That is the IP address of the source and destination. Ethernet is the delivery message from one NIC to another NIC on the same Ethernet local area network connections. So that is probably a from peer-to-peer or from star network where the host devices interconnected to transfer data or information using wired or wireless. Not because the network interface card we have governed by the 802.11.03 for the wireless and 802.11.2.3 for the wired. Network protocol suites. So protocol must be able to work with other protocols. So there should be a compatibility. A group of interrelated protocols necessary to perform communication function, a set of rules that work together to help solve a problem. Then the protocol are viewed in a term of layer, higher layers to lower layers. Example on the simulations on your illustration, two persons on a physical layer, the conversation protocol suite, the use of language, wait for your turn, signal when finished. So if you are talking to your friend using your mobile phone, you are calling your friend, there should be one talking, the other one should be listening. If you're both talking and listening, okay, it's up to you if you can digest what the other is telling. Then the content layer. Evolution of protocol suites. So there are several protocol suites, the TCP/IP and the Open System Interconnect or the OSI. So under the TCP/IP, the most common protocol suite are maintained by the Internet Engineering Task Force, wherein for the OSI, it's under International Telecoms Union. The AppleTalk proprietary suite by Apple Incorporated. The Nobel Network. I don't know if the Nobel Network still exists. Probably they are already phased out. TCP/IP protocol. Example, we have the application transport internet and network access. So for you guys, the key or the shorthand for this sequence is ATINA. ATINA, application, transport, internet, network access. ATINA. Okay. So this layer has also an equivalent OSI layer later. I will show it. On the TCP/IP model, we have here the application layer, transport layer, internet layer, and network access layer. Each layer has their own protocols. Example, application layer. You are using a browser. So using either your key in HTTP or HTTPS protocol. On the transport layer, this command will be transmitted or it will be converted to port number. Example, HTTP is port 80, HTTPS is port 443, FTP is port 20 and 21, SNTP is port 25. So those ports are converted on a transport layer under the TCP and UDP. Then the internet layer, this is responsible for addressing We have the IPv4 and IPv6 and network address translation. Also for echo, the ping, the and routing. This is for the router to communicate each other. So using the multicast addressing sa open shortest path first, the enhanced interior gateway routing protocol, and the border gateway routing protocol. Network access or network access layer, this is your protocol that happens on your address resolution protocol, Ethernet, and wireless LAN. What are these? These are your network interface card, physical address, the MAC address, and the logical link controller. This is under the data link. So either you use the carrier sense multiple access over collision detection, or you'll be using the wireless, which is carrier sense multiple access over collision avoidance. So the Ethernet is 802.3, 802.11 is for the wireless. TCP/IP communication process. So example of this are encapsulating the protocol data unit from your higher order, from your application to transport to internet to your network access. So the information or the data to be transferred to other from sender to receiver, there are packing or just like sealing of important chunks. So from here, the data, probably this is from your application, then a segment from your transport. For your internet, we will be adding the source IP and destination IP. For your Ethernet, we will be adding the source MAC address and destination MAC address, and the start and end of your frame chunk. Okay. It's like just like I said, it's like a jigsaw puzzle wherein if this client example is browsing a web server here and requesting for HTML file or PHP file to be viewed on his browser. So those messages will be transferred on a chunk messages. It's like a jigsaw puzzle that where the client will be creating or piling until it makes a whole. Or standard organizations. So we have here the open standards, IEEE, the IETF, the IANA, ICANN, ITUN, TIA. Those are the standard organizations who manage these protocol suites or managing the IP address. Internet standards, who are the responsible? So as you can see, the Internet Society is the upper under the standards, then it will be on the Internet Architecture Board, then is escalated to IATF, IRTF, then to the others. So it's just like who are the responsible for governing. So for internet standards, we have the ICANN and IANA. So Internet Corporation for assigned names and numbers, coordinates IP address allocation, manage the domains, and assign other information. For IANA, overseas managed IP address location, domains, and management protocol identifiers, and ICANN. As you can see, we have the ARPANIC, ASIANIC, like that. They are just partitioning the IP address globally. Next. This is the IEEE. The function dedicated to create standards in power, energy, healthcare, telecommunications, and networking. Whereas the IETF or EIA develop standards relating to electrical wiring connectors and 9-inch racks used to mount the networking environment. So they are the one who's responsible for example are the cable, the STP, and the UTP cable, the coaxial, fiber optic. They are the one who is in charge for the development. Telecommunication Industry Association developed the communication standards in radio equipment, cellular towers, voice over IP devices, so they are responsible for the technology equipment used nowadays. The International Telecommunication Union telecommunication standard sectors defines a standard the video, though the one setting for the standard for video compressions, internet protocol for televisions, broadband communications such as digital subscriber line. So, reference model. So as you can see here, you have the OSI model compared to the application TCP IP model. So the three chunks of the OSI model is equivalent to one chunk of the TCP IP model. So transport, they are the same. Internet and network are the same. But for the data link and physical, this is the network access we are talking about. So at Athena and application presentation session, transport, network, data link, and physical for the OSI model. Benefits using the layered model. So assist protocol design protocols that operate specific layer, foster competition because product from different vendors can work together. Oh, that's good. Prevent technology or capability changes in one layer from affecting other layers above and below. Provide a common language to describe network functions and capabilities. So OSI model, these are the description in each model. So just read it. The purpose of this transport, this will be handling the TCP and UDP. So the services to segment transport resembles data. All of the application presentationization here under the PDU, Protocol Data Unit, is just a data. Data, you are managing the data. Then there's the segment. The transport here will be the segment that will be the use of the port addressing scheme. Internet will be using the IP addressing, and the data link will be using the physical addressing, and what media will be used to transfer or transmit those messages. Under the TCP IP model, we have 4: application, transport, internet, and network access. So to differentiate, as you can see, okay, packet tracer activity, messaging, segmenting messages. So, segmenting is a process of breaking up messages into smaller units. Multiplexing is a process of taking multiple streams and segmented data and interleaving them together. So those are segmenting and multiplexing. what's the indicator of this? It is to transferring message over the server or requesting message to a server, either of the two, transfer or request, upload or download. They are just sending the messages or chunk of messages over a wire or wireless until it will be readily available as a whole. Those chunk messages will be converted into whole in this server. So increased speed, large amount of data can be sent over a network without tying up the communication thing. An example of this are what are the bandwidths available in these sections or this media. If you're using fast Ethernet, the maximum is 100 Mbps. If you're using gigabit Ethernet, you're using the 1000 Gbps. But you cannot use all those if you are transferring messages. We have a term good put and throughput. So that will be a chunk of messages, how long it will be delivered to the receiver and how much this receiver can only receive those chunk messages because it requires controlling. So you can hear here the sequencing. So they are in between the chunk of message. They are not colliding. That is sequencing. Encapsulation. So the process where the protocols add their information to data. So this is the protocol data unit. As you're using the TCP/IP model in the protocol data unit. So the data is under the application of the TCP/IP model. The segment is under the transport. Packet will be under the internet, and the frame will under the network access. For OSI, the data under the application, presentation, session. Segment is for the transport. The packet is the network. Frames will be the data link, and bits for the physical. So here is the chunks of messages or the what do you call this, the protocol data unit, how they encapsulate top-down approach. The encapsulation, once the message already received by the recipient, it will convert those bits into a data. So how is that? Let's use the packet tracer. If this PC, you are browsing example, the PC will now transfer the message from, if you're using OSI, 7, 6, 5, 4, 3, 2, 1. Okay. The 1 now will be the physical. There will be an electrical pulse here. How about the switch? If the switch now will receive those bits, the switch now convert it. Since this is a switch, the switch only knows layer 2. It will, from the port pass Ethernet serial wire, it will accept that series of 1 and zeros from 2, 1. Because 7, 6, 5, 4, 3, 2, 1, 1, 2 from the switch. Then if we have here a example, we interconnect this console to a computer, it will now transfer those messages here to the pass Ethernet serial 3. It will convert again into electrical pulse again here. So the switch on the forward frames because layer 2 is a frame. Next is this computer from pass Ethernet 01 will receive the message, a chunk of message, and convert it into a readable message. 6, 5, 4, 3, 2, 1, like that. Ayan. It will read the message from bits to frames to packet into segment and data. Okay, it is the sender. Example, this is a sender. In order for this PC to view that message, it requires he will be the receiver. Okay, like that. Network access. We'll be using the physical data network transport and other ports. As you can see here, the timing will be on the physical, then source and destination MAC address, the source and destination IP address, and the port address you're using. If you're using browser, this is probably port 80 or port 3, and the data you will be transmitting will be encrypted using the encapsulation and the encapsulation on the recipient. So the layer 3, we have the source IP and destination IP. So if your computer here is 192.168.1.110 and you're communicating with the server with 172.16.1.99, it will create a encapsulation where placing the source IP and destination IP. Then the same with the IPv6. How about device on the same network? Oh, okay, let me discuss to you that if you are transferring message to a local area network, the placing of MAC address are the destination MAC address is the same. But if your computer is communicating from a server over here, we are replacing the destination MAC address of the MAC address of your router. That's the rules. It's like you are removing you're not using the destination MAC address of a recipient. You're using the next hop MAC address, which is the router, for the destination MAC address. Role of data link layer addresses, same IP network. So the MAC address are physically embedded into Ethernet network interface card and local area card. What happened? So the role of data link layer, the same IP network. Okay, the MAC address are physically embedded into Ethernet and local addressing. So the source MAC address will be the originator on the link. So the destination MAC address will always be on the same as the source, even in the ultimate destination. As I told, if you are on the same network, you are sending a message from your PC to a server without transferring to other network, you are just using the destination MAC address, which is the server, the file server. But if you are communicating with the server to the other network, the destination MAC address will be replaced by not the MAC address of the server, but the MAC address of your router. Device on remote network. So what happened when actual destination is not on the same LAN and is in remote? So that's what I told you, that we are just replacing this MAC address, not the MAC address of the server here, but the MAC address of your next hop, which is your router. The role of network layer address. So the source and destination are different network portion. This means that they are on different network. So example of this, if these are your source and this is your destination, we are placing the source IP address of this computer and the destination, which is the target web server. But we are not changing the MAC address. We are just only changing the destination MAC address, because that will be your router. Default gateway. So the default gateway is your router. If you are using the IP address, subnet mask, and the default gateway of this computer, the default gateway will be your router, because the purpose of gateway or the router is to interconnect with other router for forwarding your packet or your message. Mhm. Or look at this. The data link, if you are communicating from PC to server, we are placing 1.1, 1-1-1-1, which is it's not the MAC address of your server, but the MAC address of your router. Data link, okay, or the same. This is just a scenario of transferring Wireshark. You will be using Wireshark. With what we have learned, the rules, the protocol suites, and standard organizations who govern these protocols. Another is data encapsulations. You already learned the TCP/IP model and the OSI model. The TCP/IP has 4 layers, whereas the OSI has 7 layers. For protocol data unit, we have the data segment packet frames and bits. Data access, so the network data link layers are provide addressing through the network. Okay, and the layer 3, which is it's just a encapsulating information from bits to frame to your layer 3 packet. So there is a interconnectivity and agreement between each layer. So that's it. So let's move on to the Wireshark example. Wireshark. Okay, let's demonstrate how to use the Wireshark. So once you have installed the Wireshark software, let's try. Click. So I'm using my wireless network here. So let's try to capture some packet from my computer. This is now what's happening on my computer. So my computer is interacting with servers probably on Microsoft. We can see here the protocol, transmission control protocol, the frames that are received, the source and destination. This is my IP address to show that using the command prompt, if I type ipconfig /all, I can see here my IP address of my wireless network. And this is my physical address and my router address as a gateway. So let's test the Wireshark. Let's try to ping cisco.com. There you go. So it's now replying. So the address of Cisco is 172.163.4.185. So let's look for our packet. Let's click stop. So let's find the ICMP. Let's click protocol. We have an ARP. ICMP, here is it. There's an echo request and echo reply from the sites of Cisco. Like here, the IP address of Cisco is 172.163.4.185, and here is it, 172.163.4.185. This is an ping command or an ICMP. So to check, we can also use nslookup command. Example, nslookup cisco.com. So we can verify here the IP address of cisco.com together with its IPv6 address. Okay. Or how about the what is my MAC address and the MAC address of my router? I simply use the ARP-A command to view the physical address of my computer on using ipconfig. You can see my physical address. You can also use the ARP-A command so that you can see the physical address of your router as well as my my computer. Here is it. Okay. So as we have discussed previously, that under protocol data unit, we can transmit a chunk of frames or messages over internet. It's like a jigsaw puzzle. We let's check one of the captured packet. So I select this one, the ping request. So my PC is requesting a response from a server. So under the frame, we can see the number of frames that has been sent from PC to server. We have a 45,432 frames with a length of 74 bytes per frame. Next, what are the protocols in the frame? We have here ICMP data. So this is a data link protocol. As I mentioned before on our discussion. On the Ethernet, so we can see here the source IP address, source MAC address, and the destination MAC address. As I told you, the destination MAC address is not the MAC address of the server we are trying to communicate. So this is the MAC address of our router. This is our MAC address. To show it to you here, to compare it, here is our MAC address, the physical address. Let's drag and show it to you. Compare. So you can see this one is E8 4E0652C511. So this is the MAC address of my computer. And the MAC address of the router is this one. So to check it, we have a C3DFA965AF9E. So they are the same. How about the source IP and the destination IP? So under the Internet Protocol version 4 or the IPv4, we can see here that this is my source IP, which is my IP address, the IP address of my computer. And the destination IP address is not my router, but instead it is a IP address of the server that we are communicating to. Okay, so that is, we have a source and destination IP here. Time to live. I have read, what is time to live here? The TTL. So we have a maximum of 255 time to live. As the packet move on the internet, it will be reduced to 1. So once the TTL is 0, then the packet will be discard or drop. Okay, so that is an example of using our Wireshark. So next is the recap. Uh, let's have a recap for this module before you take your online exam. Let's have a chapter or module 1 review. So I already uploaded this to your Edmodo account. Kindly read before you take your Edmodo quiz and your NetAcad account module exam. So the module exam will be covering the chapter 1, 2, 3. So probably there will be a 65 to 75 questions, multiple choice or matching type that you will be experienced in this examination. So let's recap for this module 1. So every computer on a network is called a host. So you need to remember those I highlighted. They will be probably be on your chapter quiz. You will be encounter those terminologies. So server are computers that provide information and devices, whereas the clients are the computer that send requests to servers to retrieve information. Remember the peer-to-peer or the PC-to-PC connection. So there are describes a network where one computer can be both client and server. So we'll be using the crossover cable as you have already experienced during your IT Essential course. So the intermediary devices are example of these are the switch, access point, wireless access point, routers, and firewalls. So they are in charge for sending your message from a specific computer to a destination computer. The purpose of a router is to determine the path that the message should have taken. So the lower the metric will be good for the router or will be the reliable to transfer the information or data or the packet over a media. Either this will be on your wired or wireless network. A firewall is used to filter incoming and outgoing traffic. So usually the firewall is checking for the port address. Usually this works on the TCP and UDP port. So a DSL modem is used to provide internet connection for home or an organization. Once you are interconnected with the internet service provider, example of your internet service provider are PLDT or Globe Telecoms, usually they provide you a DSL modem on your home. That will be the demarcation point from your home connection to your internet service provider. So a client server is a term describes computing model where server software runs on a dedicated computers. Whereas servers, so example of these servers are the web server, email server, or file server. They are special software installed on that network operating system for the client to cater those services. Soho network or small office or home office network is a term describing a type of network used by people who work from home. Now, nowadays, the pandemic season or what happening on the COVID-19, most of our BPOs and call centers, they work from home. So they need a reliable internet connection nowadays. So most common types of network. We have the local area network and the wide area network. If we are talking about local area network, we are referring to small geographic area. Whereas the wide area network, we are referring to large geographic area. Mostly the wide area network is part of a internet service provider where they interconnect to other servers or intermediary devices for data transmission. So the internet is a worldwide collection of interconnected LANs and WANs because servers around the world, you can browse to whatever sites uh, you want to browse for as long as it is available or there is a domain name for that sites. Remember, the intranet is used for private connections for its employee only. So the organization's employee use this network. We call it intranet. So for extranet, as I mentioned before, these are used by your customers or the suppliers to connect on your intranet networks. So, example of these are the commissary, supply chain management, where you the client can or the customer can place order through your net. Okay, digital subscriber line. So these are our means of communication right now. The DSL. So using the telephone lines, there are high bandwidth connection that runs over telephone lines. PLDT, my DSL, example, Globe. Usually the ISP with a telephone. So another is cable. So example of these are the converged ICT, where cable TV and cable internet as their service providing. Dial-up telephone. So this is slower and cheaper, but nowadays it's already phased out. During 1990s, they use cards and dial-up modem for these connections. Satellite transmissions, so it requires a clear line sites and is affected by trees and other obstruction because satellites are orbiting on the Earth. So we are using the radio transmission. Mhm. Next is the criteria for choosing a medium are the distance, the selected medium that can successfully carry signals. The environment is in which a selected medium is to be installed, the amount of data and the speed of which the data must be transmitted. So these are the criteria. Network architecture. So what are network architecture? It refers to the technology that supports infrastructure that move across the network. So if you are using wired or wireless, those technologies that interconnect must support this architecture. There are four basic characteristics that underlying architectures. One of those are the fault tolerance, scalability, quality of service, and security. If we are referring for fault tolerant network, so a limits the impact of failure by limiting the number of affected device. So if there is a one area of internet service provider has no internet connection, must not affect all. So just as a selected geographic area. So other services for that area should be or must be active. The fault tolerance refers to provide redundant links and devices. So what are the fault tolerance? So example, these are you probably create a mesh network or a partial mesh network where if in absence of the device, it can be divert those connections to the other device. So scalable network can expand quickly and easily. So you can add additional equipment, intermediary devices, host devices that makes a greater number of devices on your existing services. That will be an scalable network. Scalability refers to the expand of network without degrading the service for existing users. So example of these are if you are connecting to an ISP, usually they offer a bandwidth 10 Mbps connection, but usually they are shared line. But still, even though they are shared line, at least they guaranteed 3 Mbps bandwidth for each end devices. Quality of service is the primary mechanism used to ensure the reliable delivery of content for all users. So quality of service is a term describe the policy that allows network device to manage the flow of data to give priority to voice and video. So that is one of the part of the quality of service. Usually this intended for the voice conferencing software or for voice over IP phone. Yan. Voice conferencing is a type of network traffic requires quality of service. How about security? Security refers to the protect of network from unauthorized access. Either this will be an internal or external threats. So nowadays, bring your own device. Or as you know, you're using your own device for this coming SEM or studying online. So bring your own device, a network trend that allows a user to access business or company network resources from their personal laptops or smartphone. Cloud. What is cloud? A term cloud describes storing personal files over servers over the internet to provide access anywhere, anytime, and on any device. So example of these cloud servers are your Google Drive, Dropbox, or even though your mega upload sites, or as long as these websites are repository sites, either free or with minimal payment, uh, that is will be a cloud. With powerline networking, the device may connect to the existing home lamp using an adapter and existing electrical outlet. So that will be a power line networking technology. An internet service provider, these are the organization that provides internet connections to businesses and individuals. For example, these are the PLDT, Globe, Smart, Converge, Signals. So those are internet service providers around Metro. Network security includes protecting the confidentiality of data that is on the network. In this case, because of confidential data made available to unauthorized users, the security characteristics of network has failed. Technically, the complex security measures such as intrusion prevention and intrusion prevention system are usually associated with business network rather than home networks. Usually, these are expensive systems. So the business, since they are protecting their information, they are required to use this. Installing antivirus software and anti-malware software and implementing firewall is usually the minimum requirements for home networks. If you're using your computer, you might be installing a free antivirus software like Avira. You can download on using your browser. You can search for free antivirus and anti-spyware available on different sites. So installing a home wireless network will not improve network security and will require further security actions to be taken. Spyware is a computer threat and a software that is installed on a computer that is secretly collecting data about websites. So we have already discussed this during your IT Essential course. So most of spyware are threats, a keylogger example is a spyware. So a RAM stores data. If you're referring to RAM, this is volatile. Once there's no power, all the information or data stored on this memory will be lost. Oh, okay. Why is it in here? Because the switch and router are using RAM. This is the startup configuration or the running configuration, while the flash we this is the special memory that stores our internet working operating systems or the uh, operating system of your switch. Flash memory is non-volatile. Mm, mm. Next, we have a modes of switch. We have here the user exec mode, the privileged exec mode, and global configuration mode. Another one is line mode. So each mode, to access it requires a command. Example, we are on the user exec mode. We need to type enable here so that we can move to privilege mode. In order to move to global configuration mode, we need to type a configure terminal command here. To move on the line mode, there are two. We can type line console 0 or line bty 0 and 4 example. So those are the mode or the switch mode. By typing the show running config, we can see the initial configurations of the or the current configurations of your switch or your managed switch. So the first part of the command here is your syntax. This is the syntax. Then this will be the keyword. Okay. Using tab, I already demonstrate before. The function of tab is to complete the partially typed command. Using spacebar, display the next screen, the question mark if you don't know what are the next commands, so you can use the question mark. Up arrow for your previous command, Control C to cancel your command, and Control Shift 6 if you want to interrupt the iOS. From example, we are using ping and trace route. Okay. So those are already mentioned here. With BTY or virtual terminal lines and console interface and privileged exec password, you can create password over this mode. So I already demonstrate it before. So before we need to follow this guideline of naming the device. So naming device, this is the host name, the command host name, okay? So at least we have a letter, contains no space, digit number. We can also use dash, okay, like in the example here. Oh, if you want to return from the default host name, you simply type no host name. For layer 2, switch virtual interface, in order for you to manage it, it requires an IP address. So we will be creating a virtual IP address for this interface. You need to type interface VLAN 1, then the IP address of the VLAN, and to turn it on, you need to type the no shutdown. Or a switch as a layer 2 device does not need an IP address to transmit frames to attach device. So because this IP address is only intended for managed switch. Okay. The purpose of switch is to forward frames. So however, when switch is accessed remotely through a network using this addressing, it must have a layer 3 address. That's why we are putting an address for the managed switch. Telnet. Access the network device through a virtual interface configured in a line. So what are the virtual interface? This one. Okay. We are typing the telnet, then the IP address of the switch virtual interface. The password configured under the line console command is required to gain entry through console port. So that is, I demonstrated before, from console computer to your switch. By typing enable secret password, you will have an privilege exec password for the privilege. So guidelines for password, at least 8 characters, lowercase, combination of upper, number, and special character, you can use it. Another is this one, avoid password, the same password. So at least your password for virtual terminal lines or console and privilege are different. Do not use common word because we can be attacked by dictionary attack by hackers. As much possible, we use Jejimon password. So example of configuration. So if we configure a virtual terminal line password, we simply go to line BTY, then type down the password. Then if we use the service, the password as encryption, the password will be unreadable. It will be encrypted on your running configuration. So to connect from that managed switch from your PC, you simply type the IP address of the switch and the password. The password will be prompt on your computer. So startup configuration and running config files display most password in plain text. So we'll usually to encrypt those password, it requires service password as encryption. To save the configuration, we need to type copy running config to startup config. So these are the procedures for creating a console password that I already demonstrate. It requires line console 0, the password, and the word login. This is how to the impact of password once you exit from your user exec mode. So configure a privileged exec password. So we simply use the enable secret, then your secret password. So the impact of this command will be on the user exec mode. Once you want to move on the privilege mode, it will prompt you a password. Oh. The use of end and exit. So if you use the end, you will be moving on a privilege mode. Whereas using exit, you are just simply degrading from higher mode to next lower mode. Example of this, we are on the line mode. By typing exit, you are just down mode. But if you're using end, automatically you will be on the privilege mode. Using secure shell is a preferred protocol for connecting device because it is already secured. So the first requirement for secure shell, at least you have a domain name. Then you need to encrypt, create a user and a password. Then implement it on your virtual terminal lines using the login local and transport input SSH. So to connect that using your packet tracer requires a SSH command, then a local user that you have created, the name of local user, and the target IP address, which is the switch virtual interface address. Then it will prompt you a password for that secure shell. Banner, message of the day. So a banner is a text displayed before you come up to a user exec mode. By typing the show IP interface brief, all the IPv4 address stored in a switch will be displayed on your screen. Example of this, if you type show IP interface brief, all the IP address on each port will be displayed on your screen. About the ping, using ping command, we can simply communicate with the target host. So we can see there will be a reply. Using trace route, this is the hop or jump of router to router. So we can see the sequence of hop count. So in several components that need to be entered when configuring IPv4 for an end device, we need a IPv4 address, subnet mask, default gateway, DNS, and the DHCP. So in real world, you can set that on your operating system by simply right-click the Ethernet. This is for the wired, and this is for my wireless. For the wired example, you want to place an IP address, simply click the IPv4 and you can statically put an IP address here and DNS address here. So I'm not using my wired connection. So that is just an example of how we are placing these addresses. If we are repairing for unicast to one-to-one connection, the example of these are your TV and your broadcasting network, a channel where you can tune in. It's an example of unicast. A multicast is one-to-many. So a specific computer can transfer a message to a group of computers. Example. And a broadcast, one computer can message to all computers on a network. Network protocols are defined how message exchange between the source and destination. It defines a common set of rules. As we can see here on the illustration, this is the TCP/IP model. Each model, they have their own protocols. Like here, we have the HTTP, the NS, the HTTP is running under the application, where the transport, the TCP and UDP ports are used. For the internet, the IPv4 and IPv6 and the ICMP. For the network access, you can use the ARP, the Wireless Local Area Network, and Ethernet under 802.3 and 802.11. So internet standards, they are governed by different organizations. We have the Internet Society, the Internet Architecture Board, Internet Engineering Task Force, and Internet Research Task Force. Standard organizations involved in development and support of TCP/IP. We have the ICANN and the IANA. For electronics and communication standards for equipment, so creators of the equipment and wirings, we have the IEEE, the EIA, TIA, and ITU-T. So they are the organizations involving in these electronic and communication standards. So an ISO organization that promotes a open development evolution that use internet throughout the world, whereas the ISO is organization, or if you read this, this is if you read this is IOS. This is International Organization for Standardization. Okay. So they are popular known from the OSI because we have the TCP/IP model. This will be with the OSI model. The IANA, an organization responsible for overseeing and managing IP address allocation, domain name management, and protocol identifiers. So to view the difference from OSI model to TCP/IP model and the protocol data unit, these are the segment or layers. We have the application, presentation, session, transport, network, data link, and physical. Whereas on the TCP/IP model, there's only 4: application, transport, network, and network access, or ATINA. Then we have the protocol data unit from data, segment, packet, frames into bits. These are encapsulation and de-encapsulation process. So on OSI, or Open System Interconnect, the data link and the physical layer together are equivalent to TCP/IP network layer access. Why? This is the TCP/IP model. These are their equivalent. Okay. That's why we have a data link and physical. So the OSI transport layer functional equivalent, or they're the same. Transport. Okay. Or the OSI application presentation session layers are functional equivalent to the TCP/IP application. These 3 are equivalent to application. Okay. Those are the description of each layer. Application layer is always a layer where data added to protocol data unit during the encapsulation process. The transport layer is an OSI layer where source and destination port number added to protocol data unit during the encapsulation, because under the transport layer, you have the TCP and UDP port. On a network layer, OSI model will use the logical address. This is the IP address, source IP, and destination IP. For the data link, we are using the source MAC address and destination MAC address. TCP IP model, so we have already viewed that previously. So these are the description Advantage of network device implementing an open standard such as TCP/IP model is that the clients and servers running different operating system can communicate with each other. Or imagine you're using a Linux operating system, the other one is using Apple Macintosh, the other one is using Microsoft. They're connecting to their own respective browser, but still you can chat with your friends, uh, or message your friends. But they are on a different technologies. So encapsulation is a process involving the placing one PDU inside another PDU. So example, data, then move to the segment will be moved on the packet will be moved on the frames, then frames will be moved to a series of electrical signals or radio frequency signals, which is one or zeros, or light signals if you're using fiber optic. Application data is passed down the protocol stack on its way to transmit across network media. So these are the data, segment, packet, frames, bits, which is already illustrated before. So internet layer is responsible for routing message through network in the TCP/IP model. So we require internet layer. We have the IP address and source and destination IP address. DNS, DHCP, and FTP are part of the ports under the application layer, because I already mentioned on this illustration before, although they are under here. Okay, just look for that. And the ARP and PPP are under network access. So look for that graph illustration. Flow control is a method that can be used by two computers to ensure that the packets are not dropped. So there are computer source to destination interchanging their information on, or they are transferring and receiving information. So there will be a flow control for them to receive the packets without throwing out or dropping or discarding the packets. Response timeout, or we're on the last. Method allows the computer to react accordingly when it requests data from a server and the server takes too long to respond. So that is a response timeout. Example of this, if you are browsing to a specific websites, then there will be a prompt from your browser that the website is probably not reachable. So there will be a request timeout or an error message on your screen. It takes too long. That is the response time. Okay, thank you guys for this as a module session. Hopefully you have learned from me. Thank you and see you next time.